Hello, welcome everyone. My name is Daniel Moyer. I'm a sales support trainer here at Briggs & Stratton Energy Solutions. Today, we're going to be talking about environmental and ESS considerations. With me today is Nathan Heston. Hello, Nathan.
Morning, Daniel.
Good morning. Good afternoon. Good evening. Hello to everybody around the world today. One couple or two housekeeping items today is this course is NAPCEP accredited. So if you're looking for your continuing education NAPCEP credits, go ahead and wait till the end of this training. My email is going to pop up and we're going to be able to email you the credits. Be sure when you do email us asking for those credits, you include your full name, first and last name, spell it out for us. We're sure to get the name correct on your certificate. Additionally, if you do have questions during the presentation, we're using the Q&A chat feature. So go ahead and enter your questions into the Q&A. It's usually a button at the bottom or the top of your screen, and we'll go ahead and get started. One thing I'm really excited about today is Briggs & Stratton and Simplify Power are one complete integrated energy solutions provider. We're one of only two companies in the entire United States that make both generators and energy storage systems. So we're able to be experts in both. That's one tech support call, one email to your sales rep, one warranty. So it's really exciting. And we're able to then use energy storage and generators to complement each other rather than compete with each other. And we're going to talk a little bit about that later. And we have other talks that go more in depth on that topic. One thing to keep in mind is we do assemble the batteries in the United States. And that allows us to have a high level of quality control. It allows us to kind of pivot and have a lot of changes when it comes to upgrading technology. And our battery management system that we use is proprietary and state-of-the-art. So again, one complete integrated solution provider, Briggs & Stratton, 115-year-old company. We're not going anywhere, so we're really excited to be part of the industry. I'm going to quickly run through some of these first slides because I want to get into the meat of the subject, but we are going to talk a little bit about market drivers, right? What's driving this market? Home as a haven has definitely come out of the pandemic. People working from home, school from home. The next item down there is existing infrastructure needs investment. And I don't mean that necessarily by not having power lines falling down, which of course is a problem. I'm kind of thinking more about the lines of, as we're moving into this electrification of everything revolution, where we're having heat pumps, EV chargers, the grid really wasn't designed for the demands that we expect to be put onto it. And we're going to need to use distributed assets like renewable solar production paired with batteries to help support the grid and have those distributed assets either on the residential side or the commercial side, or so-called behind the meter or ahead of the meter. Definitely climate-related disasters are promoting people adopting resilience with energy storage systems. But I would also talk a little bit about perhaps other kind of causes for the grid to go down, which may be sabotage, and the idea that somebody with a rifle can shoot up a substation and take out power to half a state is something that's real. It's something that's happened. So by having distributed assets on our home, we're able to keep our power on. Growth of clean energy subsidies is definitely exciting. You can now, with the IRA, now take a 30% tax credit on just storage alone. Historically, you've always had to pair that with solar plus storage. Now we can put just storage alone and take that 30% tax credit. There's also opportunities of doing a 30% direct cash payment. So a lot of nonprofits like churches or houses of worship, they're nonprofits, right? They don't pay taxes. So you can't take a tax credit if you don't pay taxes. Well, now with this new IRA, you can now take a 30% tax direct cash payment and leverage those clean energy subsidies. Those have now been extended through 2033. In a way, I always kind of liked the idea of those subsidies always on the verge of going away, because it allowed us to create urgency when we were sitting down with our homeowners and with our business owners. And you know, it's going to go away. You got to sign up now. And so it helped me make a sale, but really I'm excited that we have now that kind of long runway now to help get people some money and get them some savings. And we really expect this industry to grow. What we also expect is people that have gone solar to add and didn't add batteries at that time to now add batteries. A lot of times people that add solar didn't go because of the price or the technology at that moment. And I'd be surprised a lot of people that have solar may not realize that if the power goes out, by design, a grid-tied photovoltaic system is going to shut itself off, right? The anti-islanding, where you don't want to be the guy or gal producing electricity, sending it back to the grid when the grid is down, and you might electrocute the lineman down the line trying to get the power back on in the neighborhood. So by pairing existing grid-tied solar with one of these AC coupling it up to one of our energy storage systems, we can create a microgrid for the home. And if power goes out in the neighborhood, we're going to disconnect ourselves from grid, and that energy storage system that we've AC coupled is going to create a microgrid for the home. As far as the grid-tied solar is concerned, the grid is still there, and it's going to keep producing and doing its thing.
So the grid produces, and the batteries end up giving us backup power to some of our critical loads, right, Daniel?
Yeah, exactly. And a lot of times what we can also do is land our solar, our AC coupled solar on the gen port, so that we're feeding that AC coupled solar into the inverter and having it still produce power and feeding that the batteries in or to the loads at the same time.
So having batteries allows you to keep both your AC coupled system up and running when traditionally it would shut down in a grid down event, right? As well as have that battery backup.
Yeah, and we've done some other talks about this, is how generators and energy storage systems differ. And one of the big things is that you noticed is that when you have one of these energy storage systems, the transfer time, which is very quick, 8 milliseconds, is so quick that you don't have to go and reset all the clocks in the house. You don't have to reset a lot of your internet devices. And additionally, it transfers so quickly that that grid-tied inverter that's now AC coupled doesn't even see the loss of grid and continues to operate and doesn't have to reboot itself. Backup power, that's definitely been something that batteries have always provided for us. But utility bill savings is something that has always been another part of the paradigm. And part of that, what I mean by, is that we've historically had time of use rates where during certain times of the day, energy is more expensive, and we can program the battery to discharge itself during those times. What's also happening here in California, where I'm located, and Nathan, is that we have a new net energy metering policy, a NEM 3.0. What happened is it went from net energy metering to net billing tariff. So no longer can you install a solar photovoltaic system in California and see a financial return on it unless you pair it with batteries. What the utilities are doing here is now essentially, if you export electricity to the grid, that you're now getting a very low return. You're getting really the wholesale rate on that electricity that the utility would have otherwise had to buy. And so what you need to do is now store the energy that you're producing during the day when you're off at work or school from your solar photovoltaic system, and then use that stored energy to discharge it during the night, so avoiding you having to buy energy from the grid. And really, that's kind of the future of the grid. And it wasn't fair for all the people that went that didn't go solar to have to help support the grid, and the utilities having to help support the grid to help support people that had solar, grid-tied solar, who are using the grid as their battery. And we got some upcoming talks on how NEM 3.0 works and the future of what this electric grid looks at like. So stay tuned for our training calendar, and we'll show you some of those upcoming trainings where we really dive deep into that. Off-grid, I don't really see that as a big thing anymore. That's historically where we got our start, but it's still part of the game, and we're one of the few companies that actually warranties our system for off-grid use. Generator optimization, the idea that you can use a generator, run the generator, shut the generator off, charge up batteries, and then not have to listen to that noisy fumes on the generator. Definitely training opportunities. Like I mentioned, we have some upcoming trainings on generator optimization, NEM 3.0, but we also have the Power Academy, which is a great learning portal available now as part of our Briggs & Stratton acquisition. So again, one of the reasons we're here to talk about cold weather, we're here to talk about environmental considerations, and one of the things that Briggs & Stratton Energy Solutions has done is think about those solutions. We have some very creative, innovative ways to use our batteries in cold weather applications, and we're going to jump into that here in a second. one of the reasons we are able to make these innovations is that we have a large research and development team standing behind us. We have a very historic team that comes out of Briggs & Stratton, 115-year-old company. So we're able to really provide that R&D research and development and kind of come up with some of these solutions. Another I really quickly we're going to plug is our large scale commercial team. I'm not the expert in it, but if you have some of these large scale teams, these large scale projects where you're looking for three-phase systems, let me know, let Nathan know, and we'll connect you up with some of our commercial based team that can help you design a system where we can get it working for you. I'm really proud of our technical support. We're usually always able to pick up the call whenever you call and be on the phone with you to help give you that support. I love our training, and that's why a lot of us are here today.
Those are great points, Dan. I do want to highlight our commercial and industrial program here. We have batteries that go all the way up to 1200 volts. We can do, as Daniel said, three-phase power. We can do that with Solarx. We've got upcoming battery releases that are working together with the 30 and 60K Solarx that are coming out. So if you have large scale applications that you're interested in speaking with us about, please go ahead and use that training email, and I can put you in touch with that team that does those. They'll help support system designs, etc.
Thank you, Nathan. What we're seeing here on the screen now is our 4.98 outdoor rated lithium iron phosphate battery with cylindrical cells. In the middle is our 6K inverter, and on the far right is our energy track app. And all of these together kind of are that three leg of the stool. Everybody likes to kind of focus in on the inverter, but really what's doing the work is that battery, and having a battery that can discharge itself and recharge itself repeatedly over years of use is very important. And additionally, having an app or having the ability to monitor the system, remotely reconfigure it is also very important. So it really takes these separate components together to really make an energy storage system work and provide that great level of service to your customers. We do have that outdoor rated battery, like I mentioned, the simplified 4.98 battery, but we have two additional indoor rated batteries. The one you see on your far left is our Phi battery, and the one next to it is our Amplify battery. And as we're getting into this environmental considerations, the batteries on the left, the indoor rated batteries, can be put into some of our BOSS cabinets, our BOSS 6 or our BOSS 12 cabinets. And these cabinets can have battery warmers put into them. So the battery warmers can keep the batteries warm, right, during cold weather applications. Additionally, we're going to talk about this here in a second, is the Amplify battery and the Simplify battery have closed loop communications that can talk to pieces of equipment, they can talk to inverters, and they can transmit their internal temperature to these pieces of equipment to help ramp down the charge rate in such a way that you don't damage the battery during cold weather, and you can use the internal resistance of the battery to slowly warm the battery up. Now, the battery on the far left does not have closed loop communications, so it's not that it's any less of a good battery, it's just that if you have an older piece of equipment, like maybe an old Outback or old Schneider or an old Xantrex piece of equipment or something like of that nature that can't leverage closed loop communications, you don't necessarily need, don't buy something you don't need, right? So there is other options. Go ahead, Nathan.
Making, Daniel. I want to jump in here and say that, there are a lot of applications where the equipment doesn't need closed loop. And there are a lot of opportunities to save money. It's still got the same good quality high-end cells in that battery, right? There's no difference in the cells between the Amplify and the Phi batteries. It's just that the Amplify offers a little bit more added features, right?
Yeah, exactly. The ability to transmit its temperature. It can also auto-populate set points in certain pieces of equipment, saving you time on commissioning. It can also transmit its state of charge very accurately, so people get that really accurate reading on the state of charge as well. We do make generators. I'm not going to spend too much time in here, but these generators are made here in the United States. We have a lot of different sizes. These are gas, either gas propane or natural gas generators. And we have also a line of transfer switches as well. One thing coming up is I'm really excited to be talking about is at the Oregon Solar and Storage Conference. It's up in Portland coming up November 7th through 9th. So if you're going to this, please put that into the chat right now and let me know you're going, because I'd love to meet you. I'd love to have a talk with you. I'm going to be giving a talk tentatively scheduled for November 9th on maximizing solar energy using battery storage. There's the QR code right there if you're interested in attending. I hope to see you there. One thing that really makes our batteries safe is chemistry. And the chemistry we use is lithium iron phosphate, lithium ferrophosphate. But additionally, what makes our chemistry, what makes also the battery safe is the form factor. We use a cylindrical form factor. Think of them as AA or AAA cells. And that, if you think about a cylinder, really has the ability to kind of contain any thermal event that may happen. And we're very proud of our safety. We've historically always leveraged lithium ferrophosphate, and we've always had cylindrical cells since our beginning. And although I do see a lot of people in the industry moving away from cobalt-based chemistries, we've always been there. Nathan, did you want to maybe break us down a little bit what we're seeing on the right-hand side here, and why maybe cold weather affects these lithium ion cells, not just ours, but anyone's?
That's a great point, Daniel, and I love the point that you made about the fact that we're using these high-end cylindrical cells inside of our batteries, right? These are steel-cased cells, hermetically sealed, which means materials can't get in or out, right? And so that makes those extra safe. We've prided ourselves on safety, but also the number of cycles. So these cylindrical cells offer us the ability to give that unlimited number of cycle, 15-year warranty, right? Which is the best warranty in the business, right? And safety is important as well. One factor that does challenge lithium batteries compared to some other batteries, right, is cold temperatures. And that's what we're going to get into today. If you look on the right, what we're showing is a cross-section of that jelly roll. So just a figure representing what you would see there. And inside the battery cell, you have an aluminum foil layer, which is covered in typically a metal oxide. We use lithium iron phosphate on that layer, the cathode side. On the negative side of the battery is the anode, that's the graphite side. And then there's a separator layer in between so that you don't have the positive and negative sides touching each other. In that jelly roll, it's called a jelly roll because the whole thing is filled with an electrolyte layer. It's an organic salt solution which allows the lithium ions to move between the cathode and the anode side. That salt solution in cold temperatures becomes very viscous and limits the movement of lithium ions between those layers. And when those movements are limited, right, it can result in problems. For instance, if you get very cold, and this is any type of lithium ion battery, if you get very cold, that graphite layer slows down the migration of lithium ions between the graphite layers. So that essentially this process called intercalation, which is the movement of lithium ions into the graphite, gets slowed down at low temperatures. And if it gets slowed enough and you're trying to charge too fast, you can end up with a buildup of lithium ions creating solid lithium metal on that graphite layer. And that can reduce the lifetime of the battery. It can reduce the it can reduce the capacity of the battery. But with time, it can even damage the battery and reduce the lifetime. And so you really don't want to be charging rapidly in cold temperatures. Most companies, what they do is when you get down to about 0 degrees Celsius, they just turn their batteries off. So you cannot charge them below 0 Celsius. Well, we have a much more innovative approach. And Daniel mentioned our state-of-the-art BMS that's inside our communicating batteries. And instead of just turning the battery charging off, we slow it down. And Daniel's going to explain a little bit later how that can actually warm the batteries up and allow us to keep charging when that sun is out. So that's essentially what's happening. And what this slide here is showing is that this is a C/2 cell being discharged at low temperatures. And that voltage versus depth of discharge profile really gets affected at low temperatures by the viscosity of the electrolyte. And so the voltage is lower at the same state of charge under low temperatures. This is due to the load-based effect. So when you're discharging the battery, there's an internal resistance of the cells themselves. And that internal resistance increases with decreasing temperature, and therefore you're getting less power, you have less available power coming out of those batteries at low temperatures. Now, that energy doesn't just go away, right? One, if you are discharging the cell, it can create heat inside the cell, warm it up, and remove that viscosity. And two, if you were to just heat that cell back up, you would be on a different curve.
Yep.
So when you are discharging at cold temperatures, this is actually data one of my students took. And when you are discharging a cell, it generates warmth and heats itself up. So it's very difficult to stay on one of these curves. A cell discharging at C/2 would never stay on an individual curve like that. These cells were encased in a circulating oil bath, and it was very difficult to hold them at cold temperatures. Yeah. That means we can use this. We can actually discharge a cell or charge a cell at cold temperatures to warm it up, and then bounce right back up to those higher curves and have that energy available. So a lot of people will speak about the effect that electric cars don't have a very good range in cold weather. Well, as soon as you heat the battery up, that range comes right back. And so we do a similar thing with our batteries during cold temperatures. We can slowly heat them up, and we can generate the ability to start charging them up in cold temperatures.
And that's the key there, is that we do it slowly in such a way that we don't permanently damage the battery. By doing that, we're able to have a pretty wide operating temperature range. So you can discharge the battery or have it sitting idle in kind of that larger range, because we're not kind of forcing the damage to it. But if we're charging it, we have to be very careful. So if we have the Phi battery, which is the non-communicating battery, we want to be pretty careful and on kind of a more narrow charging temperature range. But using the amplified battery, which can communicate and can tell an inverter what the appropriate charging rate is based on its temperature, we can then charge the battery slowly using the internal resistance. And like Nathan had mentioned on that previous slide, we can kind of jump up to one of those other curves. So as you can see on the right-hand side, we have a picture of one of our amplified batteries. The Simplify 4.98 outdoor rated battery has the same battery management system. Those device and battery ports are the communication ports. You run either Cat5e or Cat6 Ethernet cable, and then it can talk to a communicating inverter. Right now, it would be a Solarc or our Simplify inverter. The chart you're seeing is the chart rate reduction. So as it gets cold, the charge rate reduces. At some point, it's actually going to just completely stop itself. But also unique to us is that as it gets warmer, we also reduce the charge rate as well. So ultimately, there are some temperature fault protection that at some point it's going to cut off. But again, it allows us to have these wider temperature windows. And historically, we've seen these energy storage systems being installed in states that never really had this problem, like California, Texas. But I'm starting to see, and I think you guys are too, these batteries being installed in New England, more northernly states like the Minnesotas, the North Dakotas, the Montanas, where these cold weather applications are becoming more common, and we have to be very careful on where we put these batteries, what kind of batteries we use, and how we program the systems as well.
That's a good point, Daniel. I want you to go back one slide. Look at that wide temperature range. Right? These batteries can operate from -20 Celsius all the way up to 70 Celsius on the charging side. Now, it does slow down, as Daniel said. It slows down to protect that battery, but that's a very broad range. And Daniel, you mentioned northern states, but we've got plenty of companies installing these batteries in Canada. Shout out to 907 Solar. I think we might even have one of their pictures. They install a lot of these batteries up in Alaska. And so just, we're getting people installing these in conditions where those batteries can get very cold. And so this is why these closed loop communications are really necessary. This is when they're really necessary to protect the batteries.
Yeah, and I mean, I'm thinking of some of the more warmer areas of like in Arizona or New Mexico, or even here in California. And we're going to talk about it as you go up in elevation, the air temperature drops. So there's definitely applications here as well. And we're thinking about these temperatures here are the internal temperatures of the battery, not necessarily the ambient temperatures. So if we are going to have these batteries in some sort of enclosure, understand that other pieces of equipment like charge controllers, inverters are going to be giving off some heat themselves. The batteries, as we mentioned, kind of give off some heat themselves. So by measuring the internal temperature of the batteries, we're able to get a very accurate measurement and avoid putting these things into a protective mode or slowing down the charge rate prematurely before that necessarily we have to, based on just the ambient temperatures. A lot of times people have these cabins, summer cabins. So if you do have a summer cabin and you're having a battery sitting there up at the cabin, you can have these batteries sitting there in storage conditions with kind of that wider temperature range. A great thing to keep in mind is that these batteries have a very low self-discharge rate, only 1% per month. So usually if you're going to be leaving the cabin, shut everything down and then come back in springtime and make sure that you get a good full first charge on the battery, and you're usually pretty good to go.
One of the nice ways to do that, Daniel, is these batteries, all of our batteries have what you can see on the top of that battery there is a built-in breaker, right? And if you're going to leave that cabin and you want to shut your system down, you don't have to disconnect anything. You can simply flip that breaker off.
Yeah, and the breaker is also great for doing installation. It adds a little bit of safety to it. And also, if you ever have to troubleshoot a battery bank, you can shut off individual batteries without having to disconnect everything to isolate and troubleshoot different batteries. But this battery here, our 5 battery, has been a workhorse for us for years. And it's always leveraged that safer chemistry and the safer form factor, the cylindrical cells. We definitely have had a lot of great success with our Amplify battery, which does have that closed loop communication capabilities. Really, it has a built-in battery management system, like Nathan said. So if it does get too cold, it's going to internally disconnect itself. But additionally, what it's going to try and do first ahead of time is communicate with a piece of equipment to tell it to slow down that charge rate so you don't damage it. So really, there's kind of 2 lines of protection there. This is what it looks like. This is the Boss 12 cabinet here in the middle. And as you can see, we have 12 batteries. You don't have to put 12 batteries in this. You can put like 2 batteries per shelf if you want, and always have the ability to come back and add batteries to it. We have the ability to expand our systems and add batteries at a future date. I caution you guys a little bit on that. Really, you don't want to go more than 2 or 3 years down the road before adding batteries to the system, because new batteries are going to kind of act like the older batteries, and as batteries age, they naturally lose a little bit of capacity, and the warranty of the new batteries is going to revert to the warranty of the old batteries, 15 years for the Amplify and Simplify. Boss 6 cabinet on the left-hand side, and we're going to show you here in a second, is you can put heating pads underneath these batteries so that they're thermostatically controlled. They use about 45 watts. They're not going to run continuously. They're going to turn on, cycle on and off, and keep these batteries warm, allowing you to run the batteries in cold weather applications. Further, we can take our access cabinet and put either a solar or our inverter, our 6K inverter, on the top half of the cabinet, and on the bottom we have the 6 batteries as well. So Nathan had already mentioned it, kind of already defined it a little bit, but there's a loss of capacities when you start to get below freezing temperatures, and when you start to get low temperatures, a potential reduction in cycle life, and really you're going to really affect the cycle life of the battery if you start charging these things when it's too cold. Now you can see this picture on the right. These panels are tilted way far up, so they're probably at a very northerly latitude, and it's probably winter, and they got these panels kicked way up to kind of capture the sun that's kind of just skirting across the horizon a little bit there. That picture in the background, the shed in the background is the power shack, right? And you can see that power. Go ahead, Nathan.
I just wanted to point out, Daniel, this indeed is in a very northern latitude. This picture was done by 907 Solar up in Alaska. And hence you're absolutely right. Those solar panels are tilted far towards the south to capture that sun that doesn't come high over the horizon. And they've got those batteries back in that shed right, to get a little bit of extra warmth and to minimize those cold, or I guess, I don't know the right word there. I don't want to say minimize those temperatures, but minimize those temperature variations, right? So those batteries stay a little bit warmer, and that solar array is capturing the maximum amount of sun.
Yeah, and that cabinet, right, that little shack there is insulated, right? And so you're reducing the different ways of heat loss, right? Convection, conduction, and radiation. So there's different ways we can lose heat, and by putting them in these structures, you can minimize those different methods of heat loss as well. So again, it's just keep in mind that if you're going to be using the Phi batteries, which are the non-communicating batteries, those don't have the ability to reduce the charge rate. So we're going to want to make sure we utilize heating pads. But there may be a potential that if you are in a cold climate and you're leveraging the Amplify or the Simplify batteries, which can tell a piece of equipment to reduce its charge rate, we may be able to get away without having heating pads. So we'll talk to us, let us know. We have sales application engineers. They're happy to work with you and help you design and really think about all these considerations when we're coming into play. You could, of course, like I mentioned, reduce heat loss via those different ways by adding insulation. And one way we can do that is insulating underneath the batteries so that we're not getting conduction kind of going through that cold metal shelf into the battery. We can then also use convection, right? We can shut down the fan, the ventilation fan, or potentially turn a fan on in hot weather temperatures. And then by minimizing radiation, right? You got a big metal cabinet sitting out there in the clear night sky. We can also think about covering it and providing some sort of overhang or something of the like to prevent radiation loss. By putting in insulation, you can also line those cabinets of those access cabinets with some of that foam board that you can see there. Again, it's only going to slow the rate of loss. At some point, the heat's eventually going to leak out, or heat will leak in, I guess is what you could say. And what we'll do is you're eventually going to need some sort of active system to heat them. And that's what you see here are these active heating pads. Now, I will say right now that we do not have an active heating solution for the 4.98 outdoor rated batteries. So if you are going to be putting these batteries outside, what I would recommend is using one of our Boss cabinets and putting them inside the batteries inside the Boss cabinet, putting insulation down, that rubber foam down first, then the heating pads, then the batteries. Nathan, did you have a comment?
Just that I wanted to reiterate that those outdoor 4.98 kilowatt hour batteries, they are not a great solution for cold temperatures if you're going to be in extreme cold. If you are going to use a cabinet, as Daniel is speaking about, only our Phi and our Amplify batteries can fit in them. You can insulate those cabinets. You can add these heating pads, as Daniel said. They are a special order item. And so if you're going to be installing these, let us know. We can get those integrated solutions. Those are wired directly into the battery BMS system and turn on when needed based on temperature.
Yeah, thank you. But what is not special order is the built-in communication capabilities of the Amplify and the Simplify batteries to slow down its charge rate. Now, if you are going to be using the Phi battery, which doesn't have the closed loop communication, there are third-party kind of solutions, and one of them is Victron. Now, Victron has a charge controller and the BMS 712 smart battery monitor, which you can use a thermistor. And what the idea here is that ideally you would have them embedded inside the cell packs inside the batteries, but you can't do that if you buy a third party. So what you'd want to do is maybe sandwich this thermistor that you see here in between two batteries, so you're getting as close as possible to the internal temperature reading of the batteries. There's other options available out there, and these things can, like we described earlier, adjust the charge rate up and down based on temperature. Hot temperature affects them as well. This is a picture here of, I believe this is somewhere in Nevada. But what we can do is similar to cold weather. We can use a thermostat to turn on fans. And also, at some point, it may be necessary to integrate some sort of active cooling system like a mini split heat pumps. And I know for some of our larger containerized solutions, we can have all of that equipment pre-installed in those containers so that it's ready to go when it shows up on site. Humidity is a big factor. I actually live in Arcata, California, up here in the North Coast, up in the Redwoods, and we're pretty close to the ocean. So we do have problems sometimes with sea salt spray and condensation. And Nathan had mentioned earlier, some of our batteries are hermetically sealed, so it is less of an effect on us. But also, keep in mind that those batteries inside the cells inside the batteries can still be affected. And so we want to keep them out of condensing atmospheres, keep them inside if we really have something that's really going to be close to that. Nathan, any comments here? We'll keep going. I mentioned this earlier, altitude affects the temperature. For every foot you go up in elevation, the temperature drops. So it's definitely, if you're up in a high altitude, you're going to have some effects. What can also be affected is on altitude is if you look carefully on some of these spec sheets on either batteries or inverters, that there's altitude limitations. And as we had mentioned earlier, we use a cylindrical cell. Well, a cylindrical cell is able to handle pressure differences better than, say, a pouch or prismatic cell. So we're able to have a higher altitude rating on our cells. Keep in mind, though, that a lot of other pieces of equipment, like the inverter, may also have an altitude limitation. For example, our Simplify inverter has a 4,000 meter limit on it. Vibration, and this is ESS Environmental Considerations. So cold weather, hot weather, sea salt spray, altitude, but also vibration. I've seen a lot of people starting to utilize these batteries in mobile applications. Nobody goes out and buy RVs anymore. People like to buy Sprinter vans or the like. So our batteries, although not officially tested for vibration resistant standards, we've seen great success on using these batteries in mobile applications. I would suggest putting some insulation under the battery to dampen vibrations, and also maybe put the batteries in such a location that they're minimize the vibration, maybe on top of the axles, for example. So as we're going to look through some pictures, this is off-grid in Montana. You can see this picture on the top left. What they've done is take their battery cabinet and added insulation. They've used a combiner box to run all of the batteries in parallel, and use them in such a way that we're running it to one central combiner box, and then doing our home runs up to the inverter or charge controller. Here's another great example, off-grid in Alaska. So we have our 3.8 amplify batteries. Actually, these might be 5s here with 2 Solarcs. We're using our wall brackets. So if you are doing something indoors, this is a great opportunity. And what you can see here, this is a heater. So rather than heating the batteries, they're heating the room. And yes, you can see a little yellow gas line here. So this is a propane heater. So the only electricity that this energy that this heater is consuming is probably to run the thermostat and run the igniter when it's called. So they probably set this heater to kick on at 32 degrees. They don't need to keep this room very warm, just warm enough so that the batteries don't go into that reduced charge rate and also don't get damaged. So lots of opportunities to keep these batteries warm. Here's a mobile application. You can see that they've really kind of tightened the batteries down, and they've also used some kind of structure on the bottom as well. Definitely hot weather applications. Again, insulation is going to keep these batteries from getting too warm. You can see that they got some Outback charge controllers here, some Outback Radian, and then they've insulated this shipping container so that it really keeps it cool during the day as well. So one thing I want to mention is that we do have a research and development facility down in Oxnard, California, right next to where we manufacture the batteries. We use third-party testing labs as well to pull our 9540 and our 9540A large-scale fire testing, as well as our UL 1973 on the battery level and the UL 1642 on the cell level. So really, you don't have to, believe me, we have third-party testings. One thing that really kind of speaks to the ability of our batteries to withstand extreme environments is this UN 38.3. What this certification allows us to airship our batteries. And if you think about the kind of environment that is experienced by anything in the cargo hold of an aircraft, right? What happens in the cargo hold of an aircraft, right? What you're seeing are rapid pressure fluctuations due to altitude. You're seeing a lot of vibration, and you're also seeing a lot of rapid thermal or temperature changes. So what we can do is by using these tests is kind of be able to prove that we do work well in extreme environments for our batteries, leveraging the lithium ferrophosphate and the cylindrical cells as well, and having our battery management system there to offer the levels of protection. So again, by having this UN 38.3, we can airship batteries to you where otherwise we might have had to truck ship them as well. There are some additional tests that they do. They short circuit the battery, and they also overcharge the battery as well. And we were able to pass these tests, and we are certified to show that. Diving a little bit closer into the UL certifications, UL 1642 is on the cell level. So those individual cylindrical cells, they subject these cells to a number of extreme a regimen of abusive cell, whether it's electrical, mechanical, or environmental regimen of tests. If we're able to pass that, we can move on to UL 1973, where they repeat those same kind of abusive regimen of tests on the battery level is here. The battery module level is what you could call it. And again, we were able to show that we were able to withstand those abusive tests. And that allowed us to, with the additional UL 1741 SB rated inverter, is incorporate that all into a 9540A approved piece of equipment. Now, what also helps inform the 9540 is our UL 9540A test. Now, it's not a certification like those previous ones I just mentioned. It's essentially they took one of our battery energy storage systems out to a UL lab in Illinois, I believe, and they wrapped some of our cells in heating wraps and then heated the cells to such a point that it caused not only the cells to vent, but also to go into propagation in such a way that it did self-propagate and got an adjacent cell to also self-propagate. And then they essentially watched what happened. And really what happened was not much. And we were able to show using our UL certification that we can be safe, and we do publicize that report unredacted on a website for anybody to review. I want to point out here that it's important to always run our batteries in parallel in such a way that you run conductors of the same gauge and the same length to a common terminal block, and then run one single home run. So you can see in this example, this cable here is kind of the same length as this cable here, how it's wrapped around. What that means is that you're not getting any resistance differential on these battery cables, and not causing one battery to work harder than the next. And the reason I chose this picture, again, it's showing them an insulated battery cabinet. And you can see that it looks like it's indoors inside of a room. So we're minimizing heat loss as well. So we're able to, whatever little heat that those batteries are producing, they're going to be contained in this cabinet as well. One thing
Daniel,
I want to mention,
what about
Nathan,
overheating, right? I mean, there also might be concerns in hot temperatures, right, for these same batteries. And so one of the nice things that it looks like the lid on this thing is hinged as well, right? So a simple design to allow heat out of the system in the summer months where it might get hotter as well. So simple cabinets like this looks like a homemade cabinet and a great design.
Yeah, agreed. And I do notice a little sensor here that may be a temperature thermistor right there that's going back to a third-party controller to adjust charge and discharge rate. I really like the unistrut that they use to kind of hold these batteries down, make sure that they're nice and secure. And again, you can notice that all of the batteries have the breakers. These are not closed-loop communication batteries. These are the Phi batteries, because you don't see the closed-loop communication ports on them. The Phi batteries are available in both 24 and 48 volts, 3.8 kilowatt hours, whereas the Amplify batteries, the ones that would have these communication ports there, are 48 volt only. one thing that we've been trying to push here is the idea that let's keep things simple when we sell our batteries. And one way to do that is selling hours of backup. What we did is we looked at some research across the country, and we discovered that most people's outages are a lot less long than they might imagine. And also we've able to look at the national average and determine how much power somebody uses on a consistent basis. What that does is making a couple of assumptions, essentially put together some packages that you can sell not based on kilowatt hours or watts or any of that kind of maybe confusing stuff to a homeowner, and just sell hours of backup. So what you're seeing here are our Simplify 4.98 outdoor rated batteries paired with our inverter and paired with our Energy Track app. Again, the app matters because a lot of people, that's how they interact with our systems now. That app that we're offering has all of the users' data housed on servers here in the United States. And we have an in-house software development team that is able to really kind of pivot and develop new features as we move forward. So as Nathan mentioned, if you're in really, really cold climates, these outdoor rated batteries may not be the best solution for you. And what we might want to look at is our Amplify battery packages that can be otherwise leveraged in an indoor application, or if you're going to do outdoor, use one of our Boss cabinets with the heating pads built into them.
So Daniel, I think it's worth breaking down, if you don't mind. We've got just a few minutes here, and I'd like to break this down for people. The way these hours are calculated, the average number of hours of backup, we're assuming that you're not going to back up everything in your home, and that during a power outage, maybe a fire has come by, or there's been severe weather, like a snowstorm that's knocked trees on a line. The assumption here is that you would probably not use quite as much electricity as normal. So you're not going to run that electric dryer, for instance. But the idea is you would probably use about 50%. You'd probably use about 50% amount of your average. And so the average home in the US just uses a little bit over a kilowatt hour on a 365, 24-hour average basis. So if you average over the full year, and take the total amount of energy you've used in a full year, divide it by 365, and then divide that by 24 hours in a day, you get about 1,000 watts. So a typical home uses 1,000 watts in America. Now there are variations in that, but they're not particularly large, right? The South uses a little bit more, the North, especially in the summer, right? And then places that are close to the coast, like Daniel and I, use a little bit less energy. The point is that about half of that energy would be used during an outage, half the amount of power used in an outage. And so you would get a power based on a number of hours based on using half of the energy that you normally do. And we've taken the capacity of these batteries and essentially divided the number of kilowatt hours by about half a kilowatt, meaning about 500 watts. That gives you, 12 hours of backup with just 2 Amplify batteries, 18 hours with 3 Amplify batteries, and a little over a full day worth of backup if you have 4 of those batteries. Now, if there, of course, are going to be variations, right? The amount of energy that's, the length of time you get out of your phone depends on how heavily you're using it. The length of time you get out of these batteries depends on how heavily you're using them. I have the Amplify 3 battery package on my home, and I use significantly less power than the typical homeowner does. I have a number of gas appliances in my home, and I also have a somewhat small home. So I get a lot more than 18 hours of backup out of this. Additionally, this is just battery backup. I have solar on my roof. So if solar is available, not only will you get that 18 hours of battery backup, but you would also keep that solar active during a grid down situation and get those number of hours coming from your solar array. And in my solar array, I'm getting about 35 kilowatt hours, 30 kilowatt hours from my solar array, especially during summer months. It might taper off a little bit in the winter. So you're getting a lot of backup here. And in fact, if you have as big of a solar array on your roof as I do, you would essentially be able to continuously back up.
Yeah, become your own microgrid.
Yes. Yeah.
Yeah.
So
great point,
that's
Nathan.
where these numbers come from. right?
Yeah.
So if you're wondering, how did we compute the hours? It's very transparent. We took the national average for power consumption, divided it by 2 to assume that you're going to use about half the amount of electrical power during an outage. And then took the number of kilowatt hours in each of those batteries, divided it by that number, and that's how we get the hours. So it's
Yeah,
pretty
and
straightforward.
it's a little closer to 1200 watts. So it's a little closer to 600 watts rather than the 1K. Yeah, 1K. And I also didn't say, if you didn't have solar to really create that home microgrid, you could also potentially run a generator. And our batteries have a C/2 discharge rate, right? So that means we can charge or discharge the batteries in 2 hours. We could theoretically, if you had a large enough a charger, inverter, and a generator, you could theoretically charge up the batteries in 2 hours, shut the generator off, and then get yourself another 18 hours or another 12 hours or another 25 hours. So I'd always suggest, start with more hours as we're sitting down with the homeowner, and then you can always kind of back the packages down a little bit as people understand what their budget constraints are. So again, it takes a lot of the kind of estimating out of the
estimations out,
estimations.
right? Yeah,
Thank
and I
you,
think
Nathan.
that's important. Daniel just mentioned the ability to maximize your generator efficiency by turning it off after just a couple of hours. So just wanted to point out that these are the hours just from batteries. If you've got solar or any other power source, you of course can get more hours than this. And we're trying to simplify things as the name goes, simplify things for that homeowner. And Daniel and I are aware that many people on this call have a great grasp of kilowatt hours and number of kilowatts being drawn and energy and power. But homeowners often just want to know, well, how much backup do I get? And this gives a good guideline for introducing this topic for them. And hence, we're a pretty big fan of these packages.
Yeah, thank you, Nathan. One last thing is I want to mention is we do have an Elite IQ installer program. So if you are an installer out there doing good work for us, please let us know. We'd love to put you on the map. We can have a lot of rolling promotions that we've occasionally update or change to get you money. You get part of a newsletter. And also, additionally, we might highlight you in that newsletter and give you a little publicity and let you know. Definitely check out our Power Academy. We just relaunched the Power Academy, briggsandstratton.com/Power Academy. There's in-person courses that we're giving all around the country. We have travel trailers where we bring these energy storage systems out. We bring the generators out to you, and we'll run through maintenance on both of them, break them down. E-learning courses where it's self-paced, where you can jump in and do it at your own time. Power Academy Live, where you can kind of jump in and have more interactive kind of Q&A and more interactive, what do we call them, office hours, Nathan?
Yep.
Live virtual courses as well. So just like you see today. Also keep an eye on our training calendar for upcoming trainings as well. We always have a lot of different opportunities as well. If you are coming back to Power Academy and we're relaunching it, if you've already been logged in before, use your same user ID, and then there's the initial password. If you don't have a Power Academy already, go to that website and you can sign up and become get your sign up and start to take some of these credits.
And notice that this is free, right? The Power Academy is free to users. You can learn, you can take courses on generators, you can take courses on batteries, you can learn about ESS products and our full lineup, all for free. And this is self-paced if you can't make these webinars, or if you know somebody that wants to learn about our products, that wants to learn about the basics of solar. We offer this for free at your own time, right? So you can do this on your own. I also want to highlight, if there are installers, Daniel pointed out that installer map. I will be, together with my boss and some of the people from Energy Solutions, I will be going to the California Solar and Storage Association meeting in Berkeley on October the 26th. If you're an installer in the Bay Area and you would like to join us as a guest at our table, we're one of the supporters of CALSA, and so we're helping to sponsor this dinner. Reach out to me. Again, Daniel's got the email on the screen, training@simplifypower.com. And if you want that NABCET certificate, Daniel, what do they have to do?
They have to email training@simplifypower.com. Give us about a day to get your credits to you, and make sure you include your full name and last name. Just go ahead and send a quick email. I need credits. Here's my name, and we'll go ahead and issue those continuing education credits. So keep in mind, if you want to go join the California Solar and Storage Association in Berkeley coming up with Nathan, email us. If you're going to be going up to the Oregon Solar Conference coming up in November, email us, and I'd love to host you up there, and we could go out to dinner or at least just have a little bit of a chat. Nathan, any closing thoughts for us today on cold weather applications and environmental considerations?
I just think it's very important to prepare and be aware, because typically in very cold environments, you have a cold spell coming through. Maybe you have that power outage from that snowstorm that comes through. You want to make sure that your backup energy system is ready for that. And Daniel gave a lot of tips today for how to make sure your system can behave, properly in cold situations. And if you have any questions about that, please do feel free to reach out to us. We're happy to talk to you. One of the things that Energy Solutions from Briggs & Stratton stands out for is customer service. So we're there. We're a 115-year-old American company. Call us. We'll help you with your system if you have questions.
Yes, thank you, Nathan. And also contact us if you have any more questions about those packages, and we'll go from there. Everybody who attended this is going to get an automatic recording of this. If you need your NABCEP credits, Simplify or training at simplifypower.com. Thank you, everyone, and we'll see everyone next time.
Thank you, Daniel.